Now let's consider some questions under digital signal processing. So our interest will just be focused on what? DTFT. I told you the meaning of DTFT from my previous videos. So if you've not gone through the previous video, please do well to go through them because it's actually the introductory part of the DTFT and you need to know the basics of DTFT. Are we together? Now I told you that DTFT simply stands for what? Discrete time Fourier what? Transform. So everything we'll be considering in our question will just be what? Discrete what? Signals. Are we together? Now, from our first question, we're actually given to find the DTFT of a DTS. DTS here simply stands for what? Discrete time signal. Are we together? So we're given a discrete signal and we are asked, how can this discrete signal be what? Applied to DTFT to give us our new question, which is what? R raised to the power of n multiplied by u of what? N. Now, I told you that when you are considering questions under DTFT, you need to be familiar with what we call our standard what? Signals. Standard what? Signals. Standard signals. And I told you that we have various standard signals, but in this course, we do consider 4 standard signals, which are what? The step signal, the impulse signal, the exponential signal, and what? And the ramped signal. Are we together? So when you have a particular question given to you, the first thing you need to do is to consider if you are given a standard signal, because it is a must. You must be given a standard signal while considering what? Discrete time signals. Are we together? So what you do first is first consider the question given to you if you have a standard signal, right? Now for us to solve this first question, let me change my pen to black and I think we are good to go. Now from the first question we are given that we are given to find x of what? N, and they said x of n will be equal to what? R raised to the power of n multiplied by u of n, right? And what was the condition given for what? Absolute value of r to be less than what? 1. Are we together? Now the first thing you do is you introduce your DTFT definition. DTFT definition. What is the definition of what? DTFT. Now I told you that DTFT, when you are considering DTFT, which is our discrete time Fourier transform, we say that if we're given a signal x of n and we apply this signal to what? A DTFT function, what we arrive at is a what? A frequency domain, which is what? X exponential what? JW. This is the concept of what? DTFT, where what you have here is called what? Your time domain, right? And what you have here is called your what? Your frequency what? Frequency domain. Now you were given that your time domain is equal to this signal here. So what do? In place of x of n, we are representing your discrete signal with a new discrete signal which you are given. Now, if you replace this with a new discrete signal, you can now have that your new time domain will now be r raised to the power of n multiplied by what? U of what? N, applying DTFT to what we have here. What are we simply going to have? We are simply going to have our frequency domain, right? Which is what? X exponential raised to the power of what? JW. Are we together? Now, what are you now seeing? You are seeing that the only parameter that is changing here is your what? Your time domain, not your what? Frequency domain. Now, in essence, they are asking you to calculate for your what? Frequency what? Domain. Are we together? Now, how do you calculate for your frequency domain? I gave you a simplified formula that you use to calculate for your frequency domain by imputing the values of your time domain. Now, what's the formula? The formula is simply what? X of what? Exponential JW is equal to sigma n will be equal to what? Minus infinity to what? Infinity multiplied by what? X of what? N, right? Multiplied by what? Exponential minus JWN. This formula was given to you with respect to the discrete signal x of n, right? So since we are giving this formula in respect to the discrete signal x of n, we know that x of n is now equal to what? r raised to the power of n multiplied by u of n. Are we together? So since we are seeing x of n here, we are replacing x of n with your new signal, which is what? R raised to the power of n multiplied by what? U of n. So you have your new frequency domain equation to be x minus what? Jw will be equal to sigma n will be equal to what? Minus what? Infinity to what? Infinity, right? Multiplied by r raised to the power of n multiplied by u of n, right? Multiplied by exponential minus jwn. Your equation still remains the same, but the only difference is in place of x of n, we are representing x of n with the new signal that was given to us, which is what? R raised to the power of n multiplied by what? U of n. Now, what's the next thing you do? Remember, I told you about standard signal, and I said for your standard signal, you need to know the standard signal given to you in your question, right? Now, let's talk about standard signal. Let's talk about standard signal. I told you you have standard what? Signals, right? Standard signals. Now, I told you that for you to know the standard signals given to you, look at your question and look at how the question is being represented. We have 4 standard signals. We have the unit step signal, we have the unit what? Unit impulse signal, we have what? The unit exponential signal, and we have the last standard signal, which is what? Unit what? Ramp signal. Now, for your unit ramp signal is denoted with what? R of what? N. This is for discrete signal. Your exponential signal is denoted with what? A exponential what? Alpha n. This is for discrete signal. Your impulse signal is denoted with what? This is your impulse signal, while your unit step signal is denoted with what? U of what? N. Now, without nobody telling you what standard signal is there, you can now see that the signals that we have there is what? Is a unit step signal. Now, why are we taking the signals to be a unit step signal? We are assuming that all signals will have what? An amplitude of what? 1. That is why we are taking them to be what? A unit step signal. But in a case where they now give you your amplitude to be 2, 3, 4, 5, or as the case might be, you are now taking that signal to just be what? Step signal, if it is what? Unit step signal. Unit step signal is telling that the signal is what? 1. But when you're now having step signal, that is telling you that the amplitude of that signal is more than what? 1. Are we together? But what we have here is what we call our what? Unit step signal. Now, since you have this to be your unit step signal, the next thing that should come to your mind is, what is now your unit step signal? Are we together? But remember, from the question which you were given, you simply have U of n, right? So what you do is you tell your examiner that U of n is a what? A unit step signal. That's the first thing that should come to your mind. Is a what? A unit step signal. Now, how do you define a unit step signal? Unit step signal is defined as what? U of what? N will be equal to 1 such that n will be greater or less than what? 0. And U of n will be equal to 0 such that what? N will be less than what? 0. This is the definition of what? Unit step signal. Now, let's go back to our question. Remember that your unit step signal here will be 1, right? And if your unit step signal will be 1, n will be equal to what? N will be greater or less than what? 0. Are we together? Now, look at the condition that was given to you from your question. They are simply giving you a condition that R will be less than what? 1. So what comes to your mind? What are those values that will be less than what? 1? Is it not 0? 0 is less than 1, minus 1 is less than 1, minus 2 is less than 1, as the case might be. But in this case, we are not considering the negative value. But what are we considering? We are considering those values that are what? Less than 1, which is what? 0, right? Now, look at your your definition for unit step signal. If u of n is equal to 0, n will be less than what? 0. So this condition here suits what? Suits the condition in your question. So you can tell your examiner that since you have, from your question, from your unit step signal, since you have u of n, right, to be equal to what? 0, n will be less than what? 0. And this condition suits your what? Your condition in your question. Are we together? So you simply have that anywhere you see n in your equation for your frequency domain, you represent that value with what? 0. Now look at your boundary condition. You were given boundary condition that n will be equal to what? Minus infinity to what? Infinity. So what do you think will be your new boundary condition equation? So from your question, you simply have that from the boundary condition, from your boundary condition, you were simply given that minus infinity to what? To infinity, right? So since you have that n will be equal to 0, you now have, since you have n will be less than what? 0, your new boundary condition will now be what? 0 to what? Infinity. So from your question, you now have your frequency domain, which is what? Sigma infinity, that n will now be equal to minus 0. What will you have here? R raised to the power of n multiplied by u of what? N, right? Multiplied by what? Exponential minus jwn. Are we together? So now remember that this was the equation for your what? Your frequency domain, which is x exponential what? Jw. This is your frequency domain. So what do? You recall that u of n is a what? Unit step signal. Unit step what? Signal. So since u of n is a unit step signal, u of n will be equal to what? 1. Are we together? Taking the amplitude of your unit step signal to be what? 1. So we are representing u of n with what? 1 in our what? Equation. So your frequency domain will now be what? X exponential jw, right? Will be equal to sigma n will be what? 0, because minus 0 is what? 0 to what? Infinity. And what we have here will be what? R raised to the power of n multiplied by what? 1. And this will be multiplied by what? Exponential minus jwn. So from what we have here, you're already telling your examiner that u of n here is a standard signal and it is a what? A unit step signal. Now, how can we simplify this equation by removing 1? You know that when 1 is multiplying everything, it still remains what? The same. So you simply have your final equation here to be what? Sigma n will be equal to 0 to what? Infinity r raised to the power of n multiplied by exponential minus jwn. 1 is multiplying this. So if 1 is multiplying this, it still remains what? The same, which is what? Exponential minus jw. Now, this is the equation for your what? Your frequency what? Domain. Remember, our interest in this question is to simplify the question to the what? Lowest term. Simplify your question to the lowest term. Now, what are you seeing here? You are seeing what? A power of what? N here. We're also seeing a power of n here. So we are simplifying this by taking one n outside. So if you take one n outside, you simply have the new value for your frequency domain to be what? X exponential jw, right? And this will be equal to sigma infinity to what? N, and n is equal to what? 0. R, remember, we want to simplify this by taking what? N outside. So if you take n outside here, you simply have r multiplied by exponential minus jw, right? So you simply have this to be r multiplied by what? Exponential what? Minus jw. And what will be the power of your question? The power will simply be what? N, such that if you use your n to multiply into this bracket, you will still arrive at what you have here. So what we just did was we just simplified our what? Our equation. Are we together? Recall from our elementary maths when we talked about geometric progression and the sequence and series, we had an equation for infinity series. If you want to get an equation for infinity series, and we said for you to get the equation for an infinity series, we have that what sigma n will be equal to 0, right, to what infinity, and this will be what a raised to the power of what n. Now this equation will be equal to what 1 divided by 1 minus what a. This equation is for what infinite what geometrical series. This equation is for what infinite geometrical series. So we are using this equation to represent what, recall that this equation is what infinite geometrical series. Somebody will ask me, why are we now recalling this equation? We are recalling this equation because what we have here is similar to what we have here. If you look very well, if you look very closely, you can see that a here can represent what everything here, and this is what raised to the power of n, with the condition that this is what sigma, which is summation of what n will be equal to 0 to what infinity. That is what this equation is having. That is why we recall the equation for what infinite what series, and we said for your infinite series equation, you will simply have that this will be equal to what 1 divided by 1 minus what a. Remember, our interest is to simplify your question to the what lowest term. You can still leave your answer to be this, right? But leaving your answer to be this will still tell the examiner that there is a way to simplify this. So why didn't you simplify it to the lowest term instead of leaving your question, your answer open it like that? Are we together? So what we are simply doing is we want to simplify our given signal to the lowest what term for somebody to understand. Are we together? So if we are to represent what we have here with this equation, we'll simply have that what we have here, which is what sigma n is equal to 0 to what infinity of what r raised to the power of exponential minus jw, all in bracket raised to the power of what n, will now be equal to what 1 divided by 1 minus, in place of a, we are representing a with everything here, such that your a now will now be what r exponential what minus jw, minus what jw. Now this is telling the examiner that you've simplified your question to the what lowest term for people to what understand. Are we together? So this is the answer for your frequency domain of your what given signal, which is what r raised to the power of n multiplied by what u of what n. Now let's go to the next question.